In this video, I'll present information from Chapter 9 of Human Anatomy and Physiology, 11th edition. This chapter focuses on muscle tissues. In particular, we'll be looking at contraction of skeletal muscle and muscle twitches. So before we get into that, you have to know that skeletal muscles are built in motor units. So a motor unit is going to include one motor neuron and all of the skeletal muscle fibers that it innervates. So here we can see in this figure there are actually two motor nerves. So we have motor neuron number 1, motor neuron number 2. And you can see that those motor neurons innervate different muscle fibers. So it looks like motor neuron 2 innervates 1, 2, 3 muscle fibers, and motor neuron number 1 innervates 1, 2 different motor or muscle fibers. So a rule of thumb here, each muscle is going to contain many motor units. So here is 2, but it can very well be dozens of different motor units within a single muscle. A second rule would be each muscle fiber is innervated by only one motor neuron. So you can see here, each motor neuron innervates multiple fibers, but each fiber is innervated by only one motor neuron. This is now going to allow for something called a muscle twitch, and that happens when one of these motor neurons is excited. So we have an action potential, let's say, traveling down motor unit 2. So that neuron is excited, and it is now going to release acetylcholine at these 3 neuromuscular junctions. And that means that these 3 muscle fibers will be excited. And so when just that one neuron is activated, it's going to cause something called a muscle twitch. So that's a response to a single action potential. It's also called an isometric twitch. This is the smallest action of a motor unit, so a single action potential. That means that those muscle fibers are excited and they are going to contract, but only slightly. Here's what it looks like electrically. So here we have the time and the amount of tension. And so we're looking, I think, at a percentage of a maximum tension. So at rest, we're near 0. And then we hit that single action potential, and you see the contraction happens, and then the muscle relaxes. We can actually break that into 3 different phases. So first, we have something called a latent period. And this is the time you'll notice that there may be 5 milliseconds between that action potential reaching the neuromuscular junction and the beginning of contraction. What's happening there is all of the molecular events of excitation-contraction coupling. So this is that action potential traveling along the sarcolemma, the opening of calcium channels from the sarcoplasmic reticulum, the cross-bridge cycling is getting initiated, and then once that happens, that's when we see contraction. And so that's phase number 2 is that contraction period. The tension is going to increase, and this is where that cross-bridge cycling is occurring. And then finally, following that period of contraction, we have a period of relaxation where the tension is returning to 0 and calcium is being taken back up into the sarcoplasmic reticulum. The duration of a muscle twitch is going to vary by muscle. So here it looks like it takes between, about 120 seconds until it's about back to 0. And you can see that's true for the soleus, but for the gastrocnemius, it's happening much more quickly. So that relaxation phase, and honestly, the contraction's happening faster. And then the lateral rectus, which is an extraocular muscle, it's quite rapid. So it looks like under 20 milliseconds is how fast this one is going through its complete cycle of all 3 phases. So those differences are going to reflect variation in the metabolic properties between all these muscles. So some are fast, some are going to be slower. But all of these are examples of single muscle twitches in these different muscles. Now, normally, the twitches are going to be added together. And so this adding together means that muscle contraction can be graded. So basically muscle contraction can be very high force or lower force. So higher tension can arise from two basic things. One, higher frequency stimulation. So throw a whole bunch of action potentials at that muscle, it's going to contract harder with more force. Or you can increase the strength of the stimulation. So basically what that means for a whole muscle level is that you're recruiting more motor units. So instead of only using motor unit 1, back in this picture, instead of only using motor unit 1, we could have a situation where we're recruiting motor unit 1 and motor unit 2. And now instead of having only 2 muscle fibers stimulated, now we have 5 muscle fibers stimulated. So the strength of contraction goes up. This is required for varying the strength of contraction. So imagine lifting a pencil versus lifting a baby using one finger. It turns out more motor units will be recruited for lifting the baby than the pencil. Additionally, it's possible that the higher frequency stimulation will happen in the latter case versus the former. So that's the lesson that muscle contractions are graded, meaning they can go at a whole bunch of different levels from low to high and everything in between. Here's an example where low frequency stimulation is just going to cause individual muscle twitches. So you can see this particular contraction has time to have the latent period, to contract, to relax, everything's back to rest before the next stimulus comes along. And so when it's slow enough, when stimulation is low enough frequency, we just see single muscle twitches. Now compare that to what happens when a second stimulus comes along before the first contraction is finished. So now we have a first stimulus, and we get the contraction, and we only get partial relaxation before the next stimulus comes along. And so now when it comes along, it actually adds to the tension. And so these stimuli are faster than the actual contraction, meaning that every time the new stimulus comes along, the tension gets higher and higher and higher. And this process is called summation. So you're basically summing, you're adding these together when the stimuli come close enough together in frequency. And this is actually called temporal summation. Finally, we can have these stimuli coming so quickly that it's going to max out the tension of this muscle. And when that happens, this is going to be called a tetanus. You can see there are two different types of tetanus. We have unfused and fused. That's just a matter of whether you can see changes in tension at the top. But in both cases, a tetanus is this plateau of muscle tension. So you've basically maxed out the amount of tension this muscle can produce. And that just happens because of the frequency of stimulations from those motor nerves. So the motor neurons are stimulating at high frequency. This is causing a plateau of muscle tension at the maximum for that muscle. In addition to higher frequency stimulation, we can also simultaneously activate more motor units. So you can have a whole bunch of stimuli coming from one motor unit, or you can have multiple motor units being activated simultaneously. So now let's say here we have one motor unit being activated. We actually don't see any creation of tension. When we have 2, 3, 4, 5, we have all of these stimuli to the nerve, and eventually we hit this threshold where it's enough stimuli to the nerve that you actually activate some motor units. And you can kind of see here, there are only 2 fibers activated there. Looks like a different motor unit was recruited here, so now there are 5, even more, and eventually all the motor units are recruited. And that's the point at which you get that maximum tension. So actually you can see in this particular figure, it looks like we hit a stimulus level of whatever this arbitrary number 7 is, and that gets us to the maximum tension. And then everything after that just delivers the same tension. So basically you've reached that maximum tension here. But the lesson here is that you can recruit more and more motor units, and that increases the tension produced. So here I'll just leave you with a question related to this generation of muscle contraction by motor nerve stimulation.